So nanocore, size matters, and why we like it small. Okay, so let's dive in right into it. What is Nanocore? Nanocore is a small company. We've been created 3 years ago. We come mainly from the defense industry, where we've been spending lots of time working in the network and cybersecurity environment. We are 5 founders. Four of us come from the French government, as I said, and Jean-Dominique, who is here, whom I've forgotten to present to you. He's my head data scientist. He will be the one to get you into the technical side of how we're using ClickHouse. Of course, it didn't take the last update. So we are perfectionists, like you can see. Everything is done in Rust in our company. We are Rustians, first and foremost. It means that when we chose ClickHouse, it was because it's the only stack we are using that is not done in Rust. So it shows how much we trust this database. What we are doing is, it's not displaying everything. I'm so sorry. Yep, okay. To give you a bit more context, I'm sorry. To give you a bit more context of the company, we are working in network monitoring and cybersecurity. We got some recognition. First of them was from the BPI, when we were awarded a Deep Tech label. We got an award at the FIC in 2022, which means it was like 2 months ago, as one of the leading cybersecurity company in IoT and OT network. And we got to join Intel Ignite, which is an accelerator program, and also Google Cloud, because we like to parallelize everything. So the last is tested by experience, yes, because our core technology, which is network probe, has been patented and tested at the utmost speed, which is 100 gigabits per second, which is our scale in all things. So if I were to start by talking about us, what we are not, it's fun. It's a really complex IT environment. And this is not us, actually. I just wanted to show you that my job is to make it so that it never becomes us. What we like with ClickHouse is it's simple, really simple. It works out of the box, and it doesn't really need a lot of optimizations in order for us to work at the speed we are pressuring the database. So it was just a bit of an inside joke. So who are we really? I have to go back on my notes, because as a Nanocore fashion, this is a presentation I finished just before I came here. So if we are, who are we really? So Nanocore is nano for network awareness for network operation. Okay, this is not our real name. The choice of that name comes from nanosecond. It's really important. As I said, we're working for high-speed networks, which are 100 gigabits per second. A network probe is meant to analyze each packet going through the network, which means that for 100 gigabits per second, we can be up to 145 million packets per second, meaning we need between 6 to 7 nanoseconds in order to classify packets, to tie it to a session, and to extract the metadata that we are sending to the ClickHouse database. So, as I said, we are not jobs, because those are metrics that are really hard to obtain. This is why we are all about speed, and speed. Once again, this is why we chose ClickHouse, because we just plugged it in and it worked. So we are not going to be really technical on the ClickHouse side, because this is what we like about it. Size matters, and usually ClickHouse is really helpful in order to make it small and ever smaller, while also being really efficient. So what for? Oh, a bit, okay, it didn't take my, sorry, okay, what for? What for? Well, a network probe, as we did, is a really light environment. In order to get 100 gigabits per second, we developed the network probe to be working on a 32-core CPU with 60 gigabits of RAM, meaning that there is not a lot of people having this kind of speed. You only find it in data centers or maybe ISPs. So it scales really well, meaning that we are able to make it work for a really small probe, like a 1 gigabit per second. We would be is working on a 1-core CPU at 2 gigahertz per second. In order to get those speeds, of course, we had to redo the drivers because the network stack in Linux is not really good. So we need to do everything in user space. This is how to show you that we are really efficient, just like ClickHouse, of course. And the way we work is we spread the probes everywhere, and every metadata is sent to data center, usually one ClickHouse for hundreds of probes. So what is network probes? Well, sorry for the bit of discoordination. Network probe will be looking at a packet. For example, for those who are not really knowing a lot about network, when you're typing a URL, like for example, nanocore.fr, the way to understand it is like, okay, I'm going to look up the website. So I know you probably kind of know HTTP. HTTP is a protocol. So you send a request. So in order to get to send a request in HTTP, first you need to send a request for a TCP connection. TCP connection is really really talkative. It gives lots of information. So as you can see, this is a theorized way of how is it working. So your computer is sending SYN to a server in order to get information. It gets a hack back, and so it's a back and forth until you have the web page displaying on your network. But it's not really that simple, actually, because you type nanocore.fr, you don't really know where it is, right? So it's on a server, but you don't really know where it is. So the first thing you have to do is to send a DNS resolution request. So it's working not on TCP, on TCP of course, but most of the time over UDP. So you're always using new protocols, even when you don't really know what they are or what they are used for. So you send a DNS request and it says, okay, nanocore.fr, it's this IP address, and your ISPs knows where to route your traffic in order for you to get the HTML page. But you want it secure, right? So in order to have your SSL, HTTPS, you have to get a SSL certificate. So this is another protocol, TLS to be exact. And so usually this is just to get a web page, and over HTTP you can have other applications. So you have a multitude of protocols. There is thousands of different protocols, and applications are just countless. So what a network probe is, it sees every packet on the network. It's able to classify each of those packets, to tie them to a session and to a protopath, what we call a protopath. So there's information, so like there is Ethernet, and after that there will be IPs, after that there will be DNS or TCP, UDP, and all that stuff. So what we do is that we see everything and we extract metadata. Metadata can be a lot of things. So it can be an IP address, like your IP and the IP of where you want to go, a MAC address. It's the identifier for your network card. It can be the protocol you are using, the application. It can be a lot of things. And each protocol have headers, which gives lots of information or not. So when you are using a VPN, you are encapsulating everything. And so the VPN is giving you information. So we take those informations and we put them in a database, like, well, ClickHouse. So for high-speed network, it's really, really difficult because it can represent lots of information. So in order for us to make it work, we have to cheat. And ClickHouse is helping us cheat a lot. And what do we do with all of those metadata? Well, it's really interesting. We do forensic, network monitoring. Some of you maybe have heard of NetFlow of SNMP. Those are protocols. They're giving information, but usually they are not really there is not a lot of information in those protocols. So what we do is we take everything and we are extracting and applying intelligence over there in order to the users, who can be a CISO, for example, or a SOC analyst, to get really good intel on how the network is behaving. Just for information's sake, we don't decrypt traffic. Okay, this is not our purview. So encrypted data stays encrypted. We don't look at the payload, just the metadata on the protocols. And with those metadata, we answer questions, which can be like cybersecurity questions. If you go back to the DNS protocol I told you about just a bit earlier, you get, for you will send a request in order to know where the IP, what's the IP of the URL you want, but DNS can be really used for nefarious purposes. For example, there are DDoS over DNS, which we can detect, of course. There could be a data leakage or data exploitation using DNS for leaking your data when a hacker is inside your network and is using the DNS protocol in order to send your data outside. So DNS is really interesting, actually, because it's the foundational block of the internet. Without DNS, you don't really know where to go. So IDS and IPS or firewalls, they are not really looking at DNS, which is why usually those tools don't really see when DNS has been exploited. So this is what we do. We do extract those data either through our tools to inform the users, or we send intelligence like syslog, or we send I'm sorry, I forgot the name, but for SOAR or SIEM tools, the extracted data and intelligence like alerts in order to help SOC analysts detect problems in the network. We do that in real time for all kind of network. And so it looks a bit like that. Yes, yeah. Oh yeah, of course I did. So let's have a look at some number, just to give you an idea of why we're using ClickHouse. 100 gigabit per second, we are doing it on a really small footprint. It's really small. I mean, maybe for you it's a big computer, but actually it's really small. 32 core at 64 gigabits of RAM. We are not really talking about packets because we don't store the packets. We don't store them in pickups, and we don't store them in ClickHouse, but we store metadata for the sessions. So for 100 gigabits per second, it can give you metrics like 14 to 15 million sessions per second, which means each sessions will be a line in the database, but not in one table, in multiple tables. It can really make it really difficult to ingest. And well, ClickHouse is really suited for this kind of work, right? Yeah, that's, and of course, the way we are using ClickHouse is to deploy hundreds of probes and to send those metadata inside one database. So the title of this presentation is Size Matters. Well, it's important because in a data center, size costs money. So when you plug a server, there is a metric for that. So 1U, I mean, maybe lots of you know about it, but 1U is just a metric, common metric, common when you have a data center, inside data centers, and it costs money. Usually it's you rent it on a yearly basis. Our opinion is like by using ClickHouse, we can manage a countless number of probes just in small footprints, which means that only with ClickHouse have been able to manage multiple probes with a really small footprint. Yeah, sizing is not for noobs because sizing is usually my work and might get to be really difficult. So when we started using ClickHouse, it was really a thorn out of my sight. So from now, I will just give the mic to my data scientist who will start speaking about one of our use cases, actually working for an ISP, and just to give you an idea of how we're managing everything.
Thank you, Florian. Yeah, so I will talk to you a little bit about a real use case with our client. So it's an internet service provider. And so the use case is to monitor the traffic from all over the world from a point of presence. So there is about 25 to today and more on the upcoming months. And so we have to especially detect DDoS attacks with a very quite small detection time. So it's less than 30 seconds. So like you see on the schema, we have different regions. So we have 5 regions: Europe, US, Asia. So we have two US and 2 Europe and 1 Asia. And with several probes, one probe with one probe per region, the ESP send us into a tunneled protocol the data to the probe from all the point of presence. And then we extract which is for the metadata, and then we send back to the database. To give you some metrics, a DDoS may represent 2 terabytes per second in terms of flow into the probe on the overall flow. And so you have to deal with a lot of flow. And so what to conclude on this presentation, what's next for us? So we want to launch new projects, new machine learning and classification project, and maybe using specific functionalities of ClickHouse, because we've seen the documentation that there are some modules, so we want to explore this way. We also want to, as Florian said, to improve, because we are very committed to performance, so we want also to improve on the ClickHouse side, on the queries, to make our queries more efficient we can. So ClickHouse is great also for traffic data, because you have specific functions for network data. So we use currently those functions. It's very useful for us. And also exploring some new features that we've seen in the last release, like for example JSON format, JSON field format, and other ones. So thank you very much, and if you have questions.
Thanks a lot. So what is the difference between that and Wireshark? Simply.
Well, we are really big fan of Wireshark. Actually, in our former careers, we started working with Wireshark. Wireshark is not a probe. Usually, it's only a reading. It could be used like a stateful kind of probe, but it doesn't really parse the packets. So there is plenty of false positives with Wireshark. And Wireshark doesn't really handle well high speed. You can do pcaps or read the network at line read speed up to 1 gigabit per second, but usually performances drop when you go higher. We are still using Wireshark on a daily basis, actually, because this is not a bad tool. What we do is a bit different. So I haven't shown you, but we put visualization tools to better understand how your network works, where networks work. And for example, we do map your network when you have a small network. So a small network would be like maybe 10 or 20,000 IPs in your network, we would be using force graph and other kind of visualizations for you to understand how it works. Usually by applying some intelligence in dashboarding with the breadth of protocols we are dealing with, we can really pinpoint quickly misconfiguration. Some of the use cases we had were for multinationals who had several implantations, locations, and they didn't really understand that by using MPLS, there were some data leakage. So using probes, a small probe that you can deploy really anywhere, it's really easy to see something like that. So Wireshark, doing that with Wireshark would be possible, but you would have to go take PCAPs everywhere on your network and to do it by hand. Actually, when we started, the first clients we talked to told us, oh yeah, I have PCAPs, but they are like 3 or 4 terabytes, and I take like between 4 to 5 days in order to parse them all and see what's inside. So by using our tools, usually it speeds up the process. And maybe I forgot to talk about it. Our approach is like Wireshark. We are CPU only. We are not using FPGAs in order to reach those speeds. Usually FPGAs are really good hardware, but Wireshark is not working with FPGAs, and usually there is not a lot of protocols given by FPGAs. So by deploying probes like us in such a network, you only need a few clicks. Okay, a bit of time to deploy several probes in your network, and you get an instant view of what is coursing on your network, which is not what Wireshark is not able to do. What Wireshark does is look at the payload, but we don't.
So we can say the main difference is the capacity.
Well, the capacity, of course, and well, the thing is, Wireshark is not a parser, meaning that if there is a malware in your network, you won't be able to see it. He will only be able to see some select protocol activities, but he's not really going deep inside the packet in order to truly see what's inside. For example, sometimes Wireshark has difficulties to understand what are the protocols after MPLS. MPLS doesn't always announce what is the protocol that follows it. So it makes mistakes because he will be looking at ports. For example, if he sees over TCP port 80 being used, he will say it's HTTP. But if it's not HTTP and somebody is using port 80, well, he might make mistakes. So it's not, well, those are...
That I noticed with Wireshark. Mainly, I'm working as IP MPLS consultant, so
okay.
I'm facing that all the time. So
okay.
Yeah, thanks.
Okay.